we will see. The first one is that is the tuned collector oscillator. Tuned collector only because of the tank circuit which is tuned in the collector circuit of the oscillator. Therefore, the name to this oscillator is a tuned collector oscillator. Now we shall see the circuit diagram of this one. So here we have a transistor, NPN transistor. So this is the RE across the emitter and CE across the emitter. Then we have here the tank circuit as this is an L which is connected in parallel with the capacitor C, so which forms the tank circuit. So another coil L2 is to be, this is L2 coupled with this one and connected to the base of the transistor. So here we have a biasing R1 and R2 resistor voltage divider arrangement is to be used. So this is a capacitor which is to be used as a this capacitor provides the low reactance to the oscillations which are to be developed across the tank circuit. So this is C1, this is L1, this is the transistor Q. Okay, and then we have the VCC supply. And a switch is to be placed over here. So this is the circuit diagram to study the tuned collector oscillator. Okay. So it consists of a transistor Q, tank circuit containing L connected in parallel with the C1. L2 is a coil which is magnetically coupled to the L1 and the tank circuit. Then VCC is applied. These are the RE and C for the emitter biasing. This is the biasing with the help of the R1 and R2 to the transistor. Voltage divider element is to be used, and the capacitor C provides the low reactance to the oscillations. So this is the circuit diagram. So now we shall say that the working of this circuit. Okay. This L2 is magnetically coupled to the this tank circuit and the coil L1. Okay. If we close the switch, say this is the VCC supply. So if we close the switch or key K, so that the collector current raises, which charges this condenser, so that the charges are to be developed across the condenser and the condenser gets fully charged. Okay. So the electrostatic energy is to be developed across the condenser C, as there is a inductor which is in parallel with this condenser C. So therefore the condenser discharges and total charges are to be dumped across the inductance L1. So the electrostatic energy has been converted into the magnetostatic energy. Then again the magnetostatic energy is converted into the electrostatic energy, keeping the same direction as per the Lenz's law. The keeping the same direction. Now the condenser will be charged in such a way that the upper plate will be oppositely charged as that of the first one. That is, the upper plate will be negatively charged and the lower plate will be positively charged. Further, there is a change in the energy again. This electrostatic energy will be converted. This totally discharges and the energy is to be developed across this one. The field is to be developed across this one. And again, as it is to be fully charged or fully the magnetostatic energy is to be developed, magnetostatic field is to be developed across the inductance L, so that this again collapses and is to be developed across this capacitor C. So in this way the oscillations are to be set up in the tank circuit. Now as this is coupled magnetically coupled with the L2 by the method of mutual induction, some voltage is to be developed. Voltage is to be developed across the L2. The frequency of this developed voltage across the L2 is the same as that of the oscillations developed across the tank circuit, but the magnitude is different. The magnitude is totally dependent upon the number of turns which are to be used across this one and the magnetic coupling of this coil L2 with the tank circuit. Okay, so this voltage which is to be developed across this one is to be applied in between the base and emitter of the transistor, and which appears in the amplified form across the collector circuit. So which is to be given as an which is to be supplied to the tank circuit as an energy, so that this whatever the losses are there, they will overcome. The losses are met because of the pulse which has been given from this, the energy which has been supplied from this side. So now the L2 is to be the number of turns in the L2 are to be adjusted in such a way, and the coupling of this one is to be adjusted in such a way that the voltage developed across this one should be amplified in such a fashion that it is just sufficient to overcome the losses of the tank circuit. Okay, so while taking the feedback, it is to be noted that the phase should be positive one. It should be in phase, that is, as this L1 and L2, as if this forms a transformer. This acts as a primary, whereas this acts as a secondary of the transformer. Now the energy which has been just transferred from this to this side. Okay, here because of the transformer action, 180-degree phase is to be shifted, and further shift of 180 degrees is obtained by the transistor properties, so that we get here totally the 360-degree shifted waveform, and this has to be given to the tank circuit, which is in phase with the oscillations of which are developed by the tank circuit. Okay, so let us have one example to see the frequency of these oscillations which are to be developed across the tank circuit is given by the formula, that is 1 upon 2 pi under root of L1 and C1. Okay, the frequency of oscillation is given by this is equal to 1 upon 2 pi under root of L1 and C1 hertz. So let us say that is this L1 is given to you, that is L1 is equal to 16 micro henries, and the value of C1 is given to you, this is 4 microfarads. So you are asked to calculate the frequency of the oscillations. Okay, we are going to take the oscillations which are undamped oscillations, and that is the continuously undamped oscillations we are expecting from such type of the oscillators. Okay, the L1 is given to you and C1 is given to you. Then with the help of L and C1, the frequency of oscillation is to be calculated. So we are substituting the values over here. 1 by 2 into 3.14 into under root of, this is 16 into 10 to the power of minus 6 into 4 into 10 to the power of minus 6. Okay, this we will get as, that is F is equal to 1 upon, if you multiply this one will be, this is 6.28 and this 16 into 4 it will be 64, under root of 64 will be 8. This is 6.28 into under root of 64 into 10 to the power of minus 12. This we will get as, this is equals to this, F is equal to 1 upon, that is 50.24. Okay, so if this multiple factor is 10 to the power of minus 6, we move to the numerator, then this will become 10 to the power of 6. So if we calculate further, so this will be, that is 0.01990. So this will be the frequency F, which is to be calculated, and this is F is equal to, if we shift this point over here, so it is multiple factor will be 3 here, 6 is as it is here, so we have a 6 multiple factor. So this will be, that is 19.1990 into 10 to the power of 3. Okay, so this point is to be shifted, so that this is 19.19 to 10 to the power of 3 hertz. So this will be, that is 19.90 kilohertz is the frequency which is to be calculated for the values of L1 and C1. Depending upon the values of L1 and C1, the frequency is dependent of the oscillations. Now, instead of this, the value of C1 which is to be given to you as 4 microfarads. So if you are given the frequency F is equal to 1 kilohertz and the L we will take, this is as a 16 microhenries. So you are asked to calculate the capacitor value. So this equals to what? So you have been given the L1 and F. So you are going to calculate the C1. Okay. So that using the same formula again, this F is equal to 1 upon 2 pi under root of L1 into C1. Right. So this under root we will take to this side, so that it will be under root of the R. We may substitute the value of 2 into 3.14 under root of, this is 16 into 10 to the power of minus 6. Okay, into under root of C as it is, into under root of C as it is. So if you shift this, the frequency is to be shifted to the right hand side, whereas the under root C will be shifted to the left hand side. So that this is under root of C is equal to the multiple factor of this one, 16 will, under root of 16 will come to be as a 4 over here. So this is 1 upon 1 divided by 6.28 into 4 into 10 to the power of minus 3, and this is a multiple factor with the frequency which is to be given to you. So here the given things are like this. For the second problem we are going to consider over here, multiplied by 1 into 10 to the power of 3. Okay, this 3, 10 to the power of 3 and 10 to the power of minus 3 will be cancelled over here, and we are left with the only multiplication of these two, that is under root of C is equal to, it is 1 divided by 25.12, and if you solve further here, this will give you, that is 0.039 0.98, and this will be under root of C is equal to this one. Therefore, C is equal to, it will be 199.49, okay, millifarads. This will be the value if we just take the under root of this one, 0.03998. So that, so if you are given the frequency f and you are asked to calculate the value of C1, so this will be like this. Okay. So by knowing the values of L and C, depending upon the values of L and C, the frequency of oscillation is dependent. Right. So this is about the tuned connection.